All right, everybody, we are going to go over the following example. It says to simplify the following rational expression. So I do have an equal sign here, but it's not like I have it set equal to something. Maybe I'm going to change my equal sign into like an arrow where I'm kind of showing it like the evolution, like the little monkey caveman to the person we are today, right? What is it, Homo erectus? I forget. So this over here, we're going to watch the evolution of this until we can get it simplified, if we can simplify it. So let's get going. How do you simplify a rational expression? A rational expression is essentially a fraction. How do you simplify a fraction? Well, I'm glad you asked. Say you have 6/16. Do I just take this and say to myself, cross out the 6's, simplified? Absolutely not. That's absolutely ridiculous. And if you did that, I would be very concerned about if you have working ears or eyes, because no one has ever done that. That's crazy times. You cannot just cross out. Think about this. You cannot just cross out a part of an expression. The numerator 6 is an expression. Just like here, x² minus x minus 6 is also an expression. You can't just be like, I'll cross out part of this and part of this. No. Not how it works. Not how it works, okay? So what do? We find factors. And again, what are factors? You have a few finite, countable number of factors. They're the things that multiply, multiplication, which we sometimes show with parentheses, to give you that thing, that number. What are the factors of 6 completely broken down? Prime factorization. So that would be bad news bears, right? So 6/16. The way you do this is how you do this. That's it. You apply the same concepts. No invention of math that you tell yourself because you tell yourself math is hard and you make up some crazy technique that no one ever showed you before. Cut it out. Stop making up your own techniques. Just do what you were taught, look at your notes, and slowly get there. It is not that complicated. 6 multiplies to 2 times 3. 16. 16. What multiplies to give us 16? 4 times 4, and then each 4 becomes a 2 times 2. So really it's 2 times 2 times 2 times 2, 4 of them. Again, these are called the prime factorization of each number. I could also have written this as 2 to the 4th power. That's another way to write it. But for right now, what we're doing, I think that's fine, okay? So no good, better, doing something, applying it here. I just brought up the phrase prime factorization. If that's a phrase that you think, I might forget that, you should have written it down. I shouldn't have to tell you. So what do we do next? When you have a common factor in your numerator and denominator, it simplifies. 2 and 2. It's a common factor. I have a 2 in my numerator and a 2 in my denominator. Fractions are also known as division. What is 2 divided by 2? What is any number divided by itself other than 0? Any number divided by itself is 1. Good, thank you, 1. So if that's a 1, then it's basically, we could cross it out. No big deal. It's not a big deal. It's just like fluff. It's like an accessory. It's making this a little, boosted up a little bit too big. So what's next? Well, I have a 3 left on top, and I have 2 times 2 times 2 on bottom, and that's an 8, and you're done. That would have been the answer, because you applied the same thing to this problem up here. We got to factor both of them. Now here, when I factored, because it was an integer, I just did a little multiplication, put a little dot in the middle. Could I have used parentheses? Sure. Could I have not done a dot? Sure. So when we factor expressions like the ones in this question up here, we tend to use parentheses because you have other expressions and you need to show that they're grouped together. This little chunk and this little chunk all go together. Beginning of the year, we did 5 factoring methods to start off the school year for more or less. Okay. So the 5 factoring methods that we did were 1, greatest common factor. 2, we did factoring by grouping. The third factoring method was the sum or difference of cubes. The fourth one was the difference of squares, specifically only difference. And the fifth one was the AC method with grouping. So really, this one's already layering one of these methods with one of these. Grouping is also including greatest common factor. They all build on each other, all right? All right, from here, I'm gonna apply that. So I wanna factor this. You should look at this and immediately think to yourself, I have a quadratic trinomial as my numerator, and I recognize this is in standard form. Again, any of these phrases that I say, if you don't know them really well, and if I had called on you and asked you what they are, write them down, put them in your work, in your paper. That's a quadratic trinomial. Quadratic is second power, and I'm going to factor this bad boy with AC method, although it's not totally necessary when the A is a 1. I'm doing it anyway. So we have 1 x squared minus 1 x minus 6. Standard form. Yes, it's ax squared plus bx plus c. It's in that style, that form, that structure. A times c is 1 times -6 equals -6. So that's how we start, AC. So we get -6. Now we make our list of factors, okay? Pairs of numbers that multiply to give me -6. Start with 1, work your way down. 1 times what? 6. 2 times what? 3. Well, 3 is next, it's already here, bottom of the list. B for bottom, B for but. But what? I need a pair of numbers that multiplies to give me that AC, but they need to add to give me B. 3 B's we talked about. Bottom of the list. And then you say to yourself, but, and then you say, gotta give me the B value. And what was the B value? -1. If you look at this pair of numbers right here, winner, winner, chicken dinner, you would use the +2 and the -3. Positive times negative is negative. If you don't know that quickly, you gotta study. Next up after that, negative or +2, you're up 2, you lose 3, you're in the whole 1, -1. That's our 2 numbers that we're gonna use, those right there. Then on the side, you would show your work if necessary for factoring. Shortcut for people who can handle it, but you have to listen because you can't use this everywhere. The minute people hear the word shortcut, they try it on everything. Don't be that person. If your A value is 1, only if your A value is 1, only if your A value is 1. If your A value is 1, once you get these 2 numbers, +2 and -3, to save time, you get x plus 2 and x minus 3. Done. Could you do it the long way where we split up the middle because it was first, it was last, and middle, FML, we split it out into FOIL, the quad, the 4 pieces, we do grouping? Absolutely. If you need help with that, I will help you with that. Someone, if you need one example of that right now, you got to speak up right now. Does anybody want me to do the grouping method now? Going once?
Yeah, can you give an example?
Yes. So I have 1x squared minus 1x minus 6. That came from my first times first because it starts off looking like this. We just don't see this right now, and that's what we're trying to figure out. This -6 came from my last times last. But here, my -1x is my middle term. The middle term, as you guys should be familiar with, is the combination of the outer and inner. When you FOIL out, first, outer, inner, last, FOIL out something in this format. Outer and inner, right? But we don't know what this is. That's what we're trying to figure out. So in order to figure it out, we need to take that middle term, M for middle, right? We have to take that FML, we have to take that middle term, remember, and split it up into 2 parts. And the way we figure out the 2 numbers is this right over here, okay? So the next step, I'm ready to split it up. I'm gonna continue my little M split right there. So now it'll be F, O, I, and L. The FOIL expanded, I see it, and I'll do grouping. So I still have x squared. I'm not gonna write the 1. I'm gonna go in this order. So plus 2x minus 3x, they get an x. Why do they get an x? It's what my B had. If this was an x to the 4th and x to the 2nd, please listen, repeat that to yourself, rewind that part, this part if you need to. X to the 2nd, and x to the 4 and x to the 2nd, then the middle 2 would have x to the 2nd. You can do this method anytime the A is with an x to a power such that The b has an x to a power that's half of that number. So 2, this is a 1. This could be a 20, that would be a 10. This could be 18, that would be 9. Okay, and you could still do this method and you would just use that proper power right there. So carrying on, -6. Then we do the grouping. You're making, anytime you do grouping, you need 2 groups or more. One group is not a group, right? It's not like you broke people into groups. You need 2 or more groups of 2 or more terms such that all the groups have the same number of terms. So if I have 4 expressions in this big expression, 4 pieces, right? 4 terms, I'm going to do 2 groups of 2. My first group is right here, x² plus 2x. And my second group is negative 3x minus 6. Underline, underline, greatest common factor. What is the greatest common factor? Stop saying the biggest thing you see. We went over this quite a bit the last 2 classes. The biggest thing they have in common is, thank you. Now what about here? What's the biggest thing they have in common? Well, remember you do that sign, so -3, right. So remember, some of you were saying these types of answers when I was asking about the least common multiple or least common denominator. So you want to make sure you're not mixing those up. Please make notes, take time, flip to that part in your notes. Stop guessing the wrong answer. Look at whatever you wrote down. Now, this underline is not only indicating each group. The underline also indicates a fraction bar, similar to these, right? And that's because when we're factoring, we're unfoiling. Foiling is distribution, so factoring and distribution, we multiply. So factoring, we're going to divide to go backwards. We're going to take that x out front. We're going to take that -3 out front. If it was just 3, you put +3. You put parentheses to show what is left on the inside. Grabbing another color pen. If we are dividing this out from the inside, we multiply it out front to keep it balanced. That's just like the x over x that you could reduce, or a 2 over 2 that you could reduce, like here. We use a pretzel to reduce because these things are both on top and they're being divided by x. It's not like you think about that too. Anyone over here that was like x and x, x² and x², and you just crossed that out. Why would you do such a thing? No one ever showed you that. You are straight up making it up. I told you here, we've been factoring all year. You learned this in classes prior. No, we never crossed out just random parts of this. Never. We did the pretzel. It had to reduce from everything. So if you cross out from one of these random spots and you're just like, I do math, you're like being a caveman. Come on, or a cavewoman or whatever. So you have to reduce fairly from everybody, okay? So again, if you just crossed out x² here, or if you just randomly reduced the 6 and 16 or the x's here, no one ever showed you that. You are just making up stuff right now. That is what I would call zero effort. That's a waste of time. That was a waste of your time and a waste of mine. So don't do that anymore. Don't do that. This reduces then to just an x and then a +2. Here we do the same thing. -3x over -3 is x. -6 over -3. Over is division. Over, fraction, is division. And that's again +2. Well, these are both in common. Guess what that is? What I refer to as your greatest common factor. It's a big chunky common factor. This, in little quotes right here, has an x +2 in parentheses, and this has an x +2 in parentheses. I'm going to factor it out front. I'm not going to show the work like I did here because this was grouping. It was like a lot going on, so you try to like break it apart. I'm just going to pull it out front. If I pull it out front, x +2 sits out front, but I pulled it out. Oh, that's not a 2. That's a parenthesis. Come on. X +2 comes out front. Now you pull it out front. It's not there anymore, right? We factored it out. Even though there's 2 of them written, it's not to the second. There's not a 2. That never happens. What's left inside? X -3. So that was the work. You guys got to have this down pat. If you are finishing Algebra 2, you are going to be able to factor. That is how this should work. And if you can't factor, did you even learn Algebra 2? I don't know. So x +2, x -3, there it is. Down here, I'm not going to go through the whole method, but you would do the same thing. A times C is 16. 16. Factors that multiply to give us 16. Pairs of factors. You're not making a list of things that go into it, like 1, 2, 4, 8, 16. That's different. I'm making pairs of factors that multiply to 16. So 1 and 16 it would be, 2 and 8, 4 and 4. And you needed the pair that B for bottom of the list, B for but you need the pair that adds to 8, 4 and 4. We said if the A is 1, shortcut, it would be positive 4 for both, x plus 4, x plus 4. Now, big deal right now, I said for the homework, which you were supposed to have turned in on that post with the video links. So if you did not do that and you said you were doing it right now, or if you came to class late today, you should be attaching that right now, or it's a 0. Otherwise, when we reduce or simplify, we don't use the word cancel, okay? We don't use the word cancel. Cancel indicates a 0. Cancel does not indicate 1. Reducing and simplifying, like here, we get a 1. Canceling is when like you combine like terms and things go away and you have like a negative 5x and a positive 5x canceled, okay? But here, if we reduce or simplify, not the same. Do we have anything as a common factor of the top and or bottom? So I have an x plus 2. I'm highlighting it yellow. Do I have another x plus 2 over here? I don't see one. Do you?
No.
All right, x minus 3, I'll highlight that green. Do I have another x minus 3 to highlight green? Not seeing it. What about, I have an x plus 4. I have another x plus 4, but can I reduce these x plus 4s with each other? Can I reduce them?
No.
No, we cannot. You're right. You cannot. If one was in the numerator and denominator, then you can. But we cannot reduce them. So what does this tell us? If you said cannot be simplified, you are amazing. There's nothing that you can simplify. Do not try to force something to happen because you think it's supposed to happen. Okay? Sometimes it just can't be done. No big deal. Cannot be simplified. End of story. Sometimes your fractions are already reduced. That's okay. No problem. If you got that right, to me, that's a sign of confidence because that was your first question that I gave for homework. And if you confidently answered it and you were like, you ain't fooling me, this cannot be simplified, then your confidence level is really up there. If you tried to force something to happen, even if your gut told you this doesn't seem like I could do anything, and you still cross something out, your confidence is down a little bit. We got to work on getting it up. Now, I also asked for the restrictions. Restrictions are like allergies, all right? Maybe you are very aware of the fact that you are allergic to peanuts, and maybe you even wear a peanut allergy bracelet because you need people to know if something happens that it might be allergic reaction to peanuts. So if you cannot have peanuts, it's like, oh, you could eat anything in the world except peanuts. No peanuts. So what about this expression? This expression, I'm just looking at it in factored form. It makes it much easier. It could eat anything it wants except something because it has allergies too. When do rational expressions have allergies, or what's their allergic reaction, or what causes it? When the denominator equals 0. It gets a tummy ache, it gets sick, its throat swells up, something happens. Denominators cannot equal 0 because you can't divide by 0. Fractions are division. Numerator, denominator. The denominator cannot equal 0. So you have this, so listen carefully right now. Do not zone out. When I say the denominator cannot equal 0, that does not mean x can't equal 0. Because if x equaled 0, I'd have 0 plus 4 times 0 plus 4 is 16. My denominator is 16. That has nothing to do with a problem. There's no issue there. X can be 0. That won't cause a problem. But what number will cause a problem? What number will cause this bubble or this bubble? They're the same, so it would be both. But what number would cause a factor, the thing in the parentheses, a factor in your denominator? Denominator, not in your numerator. Listen, do not make stuff up. What number or numbers would cause your denominator to have a bubble with 0? Because remember, 0 times anything is 0. So what do you think, Paige?
-4.
Exactly. Now, some of you will do it with your brain and your eyes, and you will be like, -4. If you are not that person, you take what's inside the factor, It's sort of like synthetic division, the box number. It's sort of even like we did a couple things like this. The vertex form of a parabola, what was the x value of the vertex? We get that opposite number, right? So in that parenthesis, a lot of the times it's the opposite number, right? But if you want to show work, you take the x plus 4, whatever is inside a parenthesis, and instead of setting it equal to 0, that would be you trying to figure out what makes it equal 0. That's what x can equal. We're going to say it can't equal 0 and solve it the same way. Get x alone. Minus 4 minus 4. That is cancel. And what do you get? X cannot equal -4. That's the restriction. Can't eat your peanuts. That's its peanuts. So that's the end of that first example. If you did this already by yourself and maybe, you didn't show the work the same way I did, but you got it correct or almost correct, then put a thumbs up on the video if you're watching it now. And if you got it wrong, put a thumbs down, and hopefully you put a thumbs up on the next one. Again, it's anonymous. I don't know who does the thumbs up or thumbs down. I can't see, so I don't care. It's just for me to keep track. And also, I know when I watch videos on YouTube, sometimes I mark it with a thumbs up when I want to know I already watched it, so that when I come to it again, I'm like, wait a minute, I already saw this. So if you mark it with the thumbs down and you're like, okay, I watched this already. At the time I watched it, I thought I was stinky at it. So either you don't want to watch it again, or maybe you do, to check if you still feel that way. Or you watch it, you come and you see you already gave it a thumbs up. That means when you watched it, you felt good about it. So you should see, do I still feel good about it, right? So it's just for your own personal inventory if you want. Okay, so that's the end of this recording. Have a great day.